Here the question is a singly reinforced bent beam of 250 by 500 mm in section is reinforced with 4 bars of 16 mm diameter with an effective cover of 50 mm. Effective span of the beam is given as 6 meters and the steel and concrete that is used as M20 Fu250 steel. The load P is acting at the center of the beam apart from the self weight of the beam. So P is acting at the center of the beam. What we have to find out? The ultimate moment resistance of the beam we have to find out. So ultimate moment resistance Mu has to be find out. So we know that D effective cover is equal to 450 mm because the cover, if you see the figure, 250 and entire thing is 500. Here the effective cover of 50, so remaining is effective depth is 450. So area of steel 4 number of bars into pi by 4 d square is 16 square, that is 804 millimeter square. So if you assume it as under reinforced or balanced section, the provided given section, so the force in compression is equal to force in tension 0.36 FCK B into XU is equal to 0.87 Fy AST, that is equal to XU we can calculate it as 97.15. XU by D is equal to 0.216. For a Fy value of 250 Newton per millimeter square, the XU limit divided by D is equal to 0.53. So it is less than XU is less than XU limit. Therefore, we can say it as under reinforced. So Mu is equal to 0.36 FCK B XU lever arm D minus 0.42 XU, that is equal to 71.81 into 10 to the power of 6 Newton millimeters, that is equal to 71.81 kilonewton meter. Therefore, from the above options, it is very relevant to option B is 70. So option B is correct. And we have to find out the centrally concentrated load P on the beam. So if you see the figure, a beam with UDL, that is self weight, and centrally concentrated load P at a distance of 3 and 3 because the span is given as 6 meters. So we have to find out P. Self weight. How to calculate the self weight? Is equal to 0.25 into 0.5 is the depth into 25 unit weight of concrete. Assumed it as 25, 3.125 kilonewton per meter. WU ultimate load is 1.5 times the actual load self, 4.68 kilonewton per meter. So P ultimate centrally concentrated load is also 1 times the P. So design moment. Mu is equal to W L square by 8 plus PU L by 4. Mu is 70 from the previous question, 4.68 into 6 square by 8 plus 1.5 P 6 by 4. Therefore, P is equal to 21.75 kilonewtons. 21.75, almost in the given options it is very near to 21. So option C is correct. And in this question the data is missing as unit weight of concrete 25 kilonewton per cubic meter. So option C is correct. Here sufficient data is given, so the questions are going to be simple. That is the logic. The question is an average operating data for conventional activated sludge treatment plant is as follows. So the waste water flow is 50,000 cubic meters per day through an aeration tank of volume this much is given. Influent BOD is given as this much and effluent is given as this much. Mixed liquid suspended solids MLSS is given as 3000 milligrams per liter. Effluent suspended solids is 40 milligrams per liter and the quantity of waste sludge is 250 cubic meters per day. So we have to find out the aeration period. Aeration period or HRT is equal to volume by discharge, that is volume is 15,500 cubic meters by wastewater flow is 50,000 cubic meters per day, that is 0.31 days. 0.31 days. The options are in terms of hours, so we are converting days into hours, that is 7.44 hours. So option A is correct. We have to find out the F by M ratio. So F is equal to Q quantity of flow into initial BOD LA. Q is 50,000 cubic meters per day and influent BOD is 200 liters milligrams per liter, that is equal to 10,000 kg per day. M is equal to total mass of MLSS. LSS mixed liquid suspended solids, that is equal to V into XT, that is volume is 15,500 cubic meters into XT, that is nothing but mixed liquid suspended solids, that is 3000 milligrams per liter, that is 46,500 kgs. So F by M ratio is equal to 10,000 divided by 46,500, that is 0.215 kg BOD per day per kg of MLSS. So 0.215 is option B is correct. In this question, in a 4-meter wide rectangular channel, the depth of flow before and after jump were given as 0.1 and 1 meter respectively. Find out the velocity of flow before jump. We have to find out velocity of flow before jump. Let me take it as V1. We have to find out. So Y1 is before jump, Y2 is after jump, the depth of flow. If you see the equation, Y2 by Y1 is equal to half minus 1 plus root of 1 plus fraud number 8f for 1 square. That implies 1 by 0.2 is equal to half minus 1 plus root of 1 plus 8f for 1 square. F for 1 we can calculate and it is coming to 3.87. We know F for 1 is equal to V1 by root GY1, that is equal to 3.87. V1 is equal to 3.87 root 9.81 into Y1 we know 0.2, that is equal to 5.42 meters per second. So option B is correct.